let's look at method of difference. Sometimes what happens is whenever a series or a sequence has been provided to you, you might not be able to find out a certain pattern they are following, whether it is an AP, GP or HP. So you have to find out the differences, common differences, and then differences of differences, so that to find out a general pattern through which you can solve the question. For example, let's take a series. For example, let us take 3, 10, 25, 48 and so on, for example. So here if you look at the first common differences, this is 7, this comes out to be 15, and this comes out to be 23. You see, there isn't any pattern here right now. If you check these differences as well, there isn't any pattern here still. So you try to take one more differences. You will get 8, and here also you get it. And further on in the, let's say this is the D1 line and this is the D2 line. So in the D2 line you will now start getting 8 only as the difference, which makes it 0 as the final one. So here you see a pattern has been followed, that in the, after taking out the second difference, it becomes common. The second difference of the terms become common. So there is a method of finding out the nth term of, if we were to find out the nth term of this series, then there is a formula. You just have to look at the first terms of all these three series that have been formed. 3 would be just normally written as 3, plus 7 would be written as n minus 1 upon 1 factorial, plus 8 would be written as n minus 1 into n minus 2 upon 2 factorial. That's it. And this way you will get an equation which is in the form of n and would be a quadratic, since n would be square in this equation. This way you can find the nth term of any sequence that has been provided to you. Let's say there had been more number of layers. Let's say there had been a D3 as well, D4 as well. Then this pattern would have continued. You would have gotten, let's say the difference would have been D, then you would have gotten D n minus 1 into n minus 2 into n minus 3 upon 3 factorial, and so on. This way this method works on. Let us solve a question to get a more gist of as to how this system works. Here again a pattern has been given: 5, 11, 19, 29 and 41. If you look at this closely, you wouldn't be able to justify what type of pattern is these numbers are following. So you find out the differences between them. Let's go to the D1 layer. This would be 6, this would be 8, this would be 10, this would be 12 and so on. Now let's try to find out D2. If you see, D1 is following a pattern. It in itself has a common difference of 2, 2, 2, 2 and so on. That means here the common difference becomes 0. That means a pattern has been formed. So you can find the nth term of this series, which would be 5 plus 6 into n minus 1 upon 1 factorial plus 2 times of n minus 1 into n minus 2 upon 2 factorial. And in the question we are asked to find the sum of first 20 terms. So let us find out what the nth term would be first. This would become 6n minus 6 plus 2 factorial, 2 cancelled out. This would become n square minus 2n minus n plus 2. N square, 6n, 2n, this would become plus 3n, and here it would become plus 1, tn. So this is our nth term of this series. Now to find out the sum of nth term of the series, Sn, we can write it as summation of Tn, where n goes from 1 to 20, since 20 has been given to us. So this we can write it as summation of n square plus 3n plus 1. And we have studied this property earlier, that whenever there is an addition in summation, we can break it down as in this manner: 3n plus summation 1. Here at all times n is equal to 20, the final value up to which we have to summate this entire equation. So now let's do this thing here. Summation Tn is equals to Sn is equal to summation n square plus, we can take the constant term out, summation n plus summation 1. So n square, we had studied about a standard result about the sum of squares of n natural numbers. So that we have to use here. It would be n into n plus 1 into 2n plus 1 by 6 plus 3 times of sum of n natural numbers, n into n minus 1 by 2 plus n. And so we continue further to solve this equation. We know n is equal to 20 for this question, so it would be 20 into 21 into 41 upon 6 plus 3 times of 20 into 19 upon 2 plus 20. And upon solving this question, you would get the sum of first 20 terms. So that is how you solve questions. Telescoping series. Now this is another method of finding the summation of series. Now this is generally used whenever you have been given any fractional series. We use this type of method. What we do is we try to write the sequence in such a manner that each term gets divided into two subparts. One is in the positive part and one is in the negative part. And what happens in the end when we try to sum all these terms together, the negative parts would get cancelled and only the positive parts would remain. That would be the first and the last or the second last term. And then through that we can find out the sum of the series. For example, here it has been shown. Let us take A1, A2, A3 up till AN a sequence, and there is a sequence B1, B2, B3 up till N. A of any n is equal to Bn minus 1. Then the sum of n terms of A1, A2, A3 would be, we can write A1 as B1 minus B0 plus B2 minus B1. Similarly, we can write for the rest of the terms as well. Now here all the negative terms and a few of the positive terms would get cancelled out. You see either the second term and the second last term have been left out, which is the Bn and B0, and through that we can find out the sum of these series. Let's take an example, look at an example to understand this concept more. Here you can see again a fractional series has been provided to you. Fractional series indicates the one which has the value of terms less than 1. So here what we can do is, we know the nth term of this sequence is 1 by n into n plus 1. So let us try to add some simplifications or add some complications to this equation so that we can make it, transform it into two subparts. One is the positive and one is the negative part. So this one here in the numerator can be written as n plus 1 minus n. If we try to solve this out, n and n would get cancelled out and 1 would remain, right? So this was just to simplify and divide it into two terms. Now there is a minus sign here, we can divide it into two separate terms. So this would become 1 by n minus 1 by n plus 1. So we've successfully been able to divide any term of this series into two. One is the positive and other is the negative. Now let's try to write down the entire series in this manner. So this would become 1 by n, which is 1, minus 1 by n plus 1, which is 2. This is the first term. Now writing the second term, it would become 1 by 2 minus 1 by 3 plus 1 by 3 minus 1 by 4, and so on will continue up till 1 by n minus 1 by n plus 1. So now if we look at this equation, this summation properly, you can see that minus half plus half would get cancelled, minus 1 by 3 plus 1 by 3 would get cancelled, minus 1 by 4 would get cancelled by plus 1 by 4 here, and similarly all these terms would get cancelled until the last term minus 1 by n plus 1. The only two terms that would remain here are 1 by 1 plus 1 by n. This solves us to n plus 1 by n. So yes, this is the answer of our equation. This was a good question, and JEE generally asks questions from this type of series, so you need to practice a lot of this series. Now we will be looking into the previous year questions that have been that have came in JEE, and we will look into the different concepts that we have studied till now, how they can be applied in those questions.